Hi, everybody. It is Friday, August 12th, 2022. My name is Man Home from Vacation, and yeah, it's time to get back at the Elixir track. So I've been away for a couple days down the shore, enjoying myself, not doing any work, and so I'm back. And the other thing that you may notice is I'm on a new laptop too, so you may notice some Mac OS changes. It's mostly, I've tried to recreate my setup as much as possible, but probably a little different. But yeah, we're gonna get started. In the last episode, I believe we did the language list, and today we're going to take a look at log level, which will work on atoms and conditions. So we'll start with atoms. And yeah, so atoms are really small. So Elixir's atom type represents a fixed constant. An atom's value is simply its own name. This gives us a type-safe way to interact with data. Atoms can be defined as followed. Variable equals :an underscore atom. Atoms are internally represented by an integer in a lookup table, which are set automatically. It is not possible to change this internal value. So atoms are similar, I think, to like a Ruby symbol, if I'm remembering correctly. But it's basically a way to create a kind of a unit value that is string-like, but is internally, a kind of a lookup table. We use atoms all the time for doing identification. So, if you're, inside of a map or a keyword list or things of that nature. The one notable thing about atoms that you have to kind of keep in mind is that atoms are the lookup table is kind of created at, I don't want to say it's not at compile time, but like I think it's created when the binary is launched. But the purpose being that you can technically create dynamic atoms. But you have to be very mindful of the fact that the atoms are the one area that like atoms are not garbage collected. And so if you find yourself creating dynamic atoms, you could run to a case where the runtime will run out of memory space for the atoms. There's like a fixed list of how many atoms you can have. This doesn't come into play too often, but it is something you kind of should be aware of. And then we've got the next topic here is cond. I don't know why they say cond. I would just say condition, but they're using the shorthand in the title. But so here we go. Often we want to write code that can branch based on a condition. While there are many ways to do this in Elixir, one of the simplest ways is to use the cond function. At its simplest, cond follows the first path that evaluates true with one or more branches. So in this case, you can do cond do x is greater than 10, y is less than 7, or true. And then you've got this arrow token, and then the value that'll be returned, in this case, atom. So this might be the way, or that way be the way, or this is the default way. If no path evaluates to true, an error is raised by the runtime. So cool. All right, and with that, we're going to be working on log level. We'll read the very first chunk here. You are running a system that consists of a few application producing many logs. You want to write a small program that will aggregate those logs and give them labels according to their severity level. All applications in your system use the same log codes, but some of the legacy applications don't support all the codes. So we've got log code 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, and question mark unknown. Log label, trace, debug, info, warning, error, fatal. Supported in legacy apps? No, yes, 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 no. I assume hyphen means no? It's kind of a weird one. But we'll get into that. So once again, we can download our exercise. I've actually already downloaded it because I wanted to make sure my Exercism command app worked on my new laptop. But I haven't touched it yet, so we can kind of get into it. So we've got our our library file, we've got our test file, and we'll open the README in a 3up environment like we usually do. All right, so we've gone through the introduction of atoms and conditionals. We've gone through the introduction, and now we can start to implement this. So to implement a loglevel.toLabel function, it should take an integer code and Boolean flag telling you if the log comes from a legacy app, and return the label of a log line as an atom. Unknown log codes and codes unsupported in legacy apps should return an unknown label. Unknown label. Okay. So yeah, so log level toLabel 0 false will return trace, 0 true, unknown. Yeah, I remember doing this one before. I thought it was a little abstract back then, but that's fine. So considering they taught us conditional, we're gonna use that here. I might not have. There are other ways, as the dictionary, as the instruction said, there's many ways to solve this problem. But all right, cool. So support in legacy apps implement. It should take an integer code and a Boolean flag. So this is the integer code and this is the Boolean flag. It has a question mark, which is good. Suggestion that it is a Boolean. If the log comes from a legacy app and telling you if the log comes from a legacy app and returns the label of a log line as an atom, unknown log codes and codes unsupported in a legacy app should return an unknown label. All right. So I'm just trying to think. I think the way, like, just to get started here, let's just looking at this very, test a cursor, looking at this very specific one that accepts a 0 and false should return trace, and a 0 and true should return unknown. So we'll say 0. So we'll say level legacy question mark. So those are going to be the incoming values, and if they go false, then we'll return trace. If it's anything else, we're going to return unknown. And we got an error. Error. Oh, does it need to be tuple? Do we learn tuples yet? Oh, I don't want that. Function con cannot handle clauses with the unoperator because it is not a macro. Please make sure you're involved with the proper name. Maybe I'm thinking of a case. I mean, you could do it like level. I don't think that's what they want. True. Legacy is not used. Yeah, this is not how I would normally write it. And not legacy. And let's do and not. Alright, let's test a cursor. That should make it pass, yeah. So let's try all these at cursor. Yeah, they're all gonna fail. Not all of them, but a lot of them are gonna fail. So level equals 1, and actually it doesn't matter. Debug. And then level 2 is info. Info. Level 3 is warning. Warning doesn't matter. Info doesn't matter. Error doesn't matter. And then level 5 does. Level equals 5 and not. Let's see. Is fatal. Then unknown. Alright, let's try this. Run at cursor. Alright, so they all passed. Yeah, this I'm not really in love with how that looks. Just looks a little quirky. I find this whole example to be a little quirky, but that's fine. Alright, send an alert. Somebody has to be notified when unexpected things happen. Implement log level.alert recipient \2 function to determine to whom the alert needs to be sent. The function should take an integer code and a Boolean flag telling you if the log comes from a legacy app and return the name of the recipient as an atom. If the log label is error or fatal, send an alert to ops. If you receive a log with an unknown label from a legacy system, send the alert to dev1 team, and other unknown labels should be sent to the dev2 team. All other log labels should be safely ignored. Oh, that's funny. Alright, so let's take a look at these ones. So we'll say condition if the level is 5 and level is 5 and false. Do they test other ones? 5 and true is dev1. Alright, let me reread this. This is like, if the log label blah 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 blah, the function should take the code and Boolean flag. If the log label is error or fatal, send the alert to the ops team. So we could do that level. What is error or fatal? Well, no. I think we'd want to reuse it, right? Label log level label true label level legacy, and then if label if label is in a list, because we already did list, so error or fatal, then that would be the ops team. If you receive a log with an unknown label from a legacy system, if legacy and label, if you receive a log with an unknown label, unknown, send the alert to the dev1 team. Dev1. Other unknown labels should be sent to the dev2 team. Label unknown. That's dev2. dev1. All other labels should be safely ignored. I don't know what they mean by ignored. We'll just say true. It returns nil? Like, what is that? What are they looking for? What's the return value they're looking for? Refute. Nil? I want to put nil. I don't know. That seems a little weird. Alright, let's test these. Describe. Test at cursor. They all pass. Alright, let's test the whole file. Test file, run all tests on file. Yeah, they all pass. Alright. Anything we don't like about this code? Requirement is a little bizarre, but it works. The label is in error or fatal. It's up. So it's legacy and labels unknown dev1 labels unknown dev2. True is nil. You see, I don't like. I mean, the fact that you have to say true is nil feels weird. That feels like a reason why a conditional would be a poor choice for this implementation, but that'll work. All right. So exercism. What is it? Upload, submit. I always forget. Submit. Yeah. Lib. Wow. I want to open it. Yeah. Cool. So we've got our iteration. Looks like it's good. We'll take a quick peek at the community solutions. Yeah, so they did it with a case, which like that was my initial like thought, but this lesson taught us conditional, and so it's going to that's why I wanted to use conditional, but that's fine. What else? So they did conditional level equals 1 and not. That looks pretty similar. What did this one do? Labels, all codes, legacy codes. That's interesting. Level in legacy codes. It's not legacy and level labels. I have mixed opinions about this. One, I mean, I kind of like the fact that they're being descriptive about like the domain here. Like they're creating this module attribute to say that like, you know, these are the legacy codes and these are all the known codes. I like that. I mean, it does kind of like create this thing like when you're looking in the function. Now, like you see these terms, and now you have to kind of reference the stuff up at the top. And you know, if you have a large module, that can make sense. But when you have a smaller module, like I almost feel like you're better off just doing stuff inline, just because it just improves the clarity of like the very small code structure. Because without that, your brain has to kind of jump around a little bit. I mean, for these examples, obviously that's a minor, you know, feedback. But cool. Yeah. So these people. This person did it with pattern matching within functions, which I don't think we've really talked about yet. Analyzer test equals 3. What is analyzer test equals 3 about? I don't know. Cool. All right. So that's our iteration. We will mark it as complete. We will publish our solution, and we have learned 2 new concepts: atoms and conditionals, and condition. We've unlocked 3 concept default arguments, guards, and multiple clause functions. We've unlocked 2 exercises: the guessing game and darts. Cool. All right, so yeah, the next episode we will go into probably default arguments and guards. But thanks for watching. If you have any feedback, definitely let me know. And we'll see you next time. Bye-bye.